Hey, good evening, everyone. In today's video, I'm going to show you how to interoperation between Swift code in iOS and the KMP project. So as you know, in my previous video, I showed you how to set up rooms in a KMP project, right? And the rooms in the KMP project supporting multi-platforms, including desktop, Android, and iOS. But in this project, and the interoperation between iOS and the common part of the KMP project is single direction, right? You composable app is in the common part, and like all your platforms use that and provide a container for that composable app, and so you can show those like UI part in each platform. But what if you want to call some functions or methods in each platform? For example, we got some setup or functions which is platform specific, which cannot be easily achieved in the common part. For example, some hardware specific stuff, right? Or platform specific, right? For example, notification, home screen widgets, alarm, and some like play a video, play a audio, right? It's those actions or behaviors related to native layer in the iOS or Android, right? So in this case, you would need the other directions invocation, right? You need, for example, we take send a notification, for example, right? And the implementation of sending a notification in different platforms are different, right? For example, on desktop, maybe you need to pop up like a message box bubble, right? And in Android, you need to use the Android SDK to send a notification. And in iOS, similarly, you will need like iOS to pop up a notification. So in this case, like you need to have an interface in the common part called, for example, send a notification. And then the implementations of this interface should be in all the specific platforms, right? You need to have a Swift code implement the send notification and implement in the Swift code and iOS part how to actually send a notification using the Apple SDK, right? So in this case, we start from the very top level. As you know, this is a common main part, like under Compose app or somewhere else is called shared, right? So you can see we create a class, expect class called native greeter. And it actually is not sending a notification because in our demo, we just want to demonstrate the process, how we interoperation, right? So we don't have necessarily to go into details about how to send a notification in all the other platforms. Instead, we do a very simple operation. We take in the name of the user and the return value is a string. For example, my name is Mike, and I will return a string, say, hello, Mike, right? And greeting from like a desktop or iOS or Android, right? So it's a simple function can demonstrate how the interoperation works. And then if you're not familiar with expect or actual modifiers, you can go back to my previous videos and or my channel. But it's not the point of today's video. So as you can see in the desktop build, right? The native greeter is fairly simple, right? Because we just simply return a string here, like I mentioned, hello from desktop and the name of the user. Because either Android or desktop, we are using the Kotlin, so it could be compiled in the same project in the IDE, right? It can achievable here. But the special case is for iOS, right? In iOS, we can still using Kotlin to accomplish this function. We can simply return a string, right? It's similar to those like in Android or desktop, say hello, Mike, username of the taken from the argument and it's from iOS, right? But it's not the point we are trying to demonstrate today. For example, if you got some more complex function, more platform specific function, and you have to go to Swift instead of like simply return or finish the job in Kotlin, right? So yeah, just note that this is you may say like, oh, you can just return a string, right? But here we try to demonstrate like how actually we achieve this job, which cannot be achieved in Kotlin, right? So as you can see here, like we set up a variable called delegate. And I won't get into details about the delegate pattern, but I think it's good for you to learn about some knowledge or context about delegate pattern. It's one of the design patterns. So if you search on Google, for example, delegate pattern, you can see more details. But like in a word, this delegate pattern is mostly like you can consider simply as a callback, right? You in your Swift or iOS code, you pass your Swift object or class to this delegate variable. And then this delegate variable invokes the function if this delegate being assigned. Otherwise, it returns like an error or placeholder. For example, in our case, it just say no delegate, right? And then we go to this folder. It's called iOS app. And if you show you the structure hierarchy of this project, you can see the common compose app is here, and the iOS app is a sibling in the same level, right? And it's also where you open your iOS project. And then inside this iOS app folder, and as you can see here, we got this iOS app Swift is already here. Before we implement this, and also the content view is already here. So what we newly created for our interoperation between Swift and the Kotlin is this new file. It's called Swift greeter.swift. Right? If you click into that, you can see here one important thing is import compose app. Right? Import this compose app actually, which is compiled in the IDEA project. Right? As you can see here, it's actually is kind of this output of this task, Gradle task, right? It's called compose app iOS simulator ARM64 binaries, as you can see here, right? And if your module is called shared in some wizard, if you generate the project, you would have shared here, right? Instead of compose app, but doesn't matter, just to let you know. And then you can see here is a static function and greet with a name and name string, and the return value is a string, right? And it return a string, like a greeting message from Swift. So that's all. So, but basically, you would know that if you got more advanced or complex features you need to implement, you can start from here, right? Whatever you want to implement in the Swift or the Xcode, for example, I can show you. Yeah, you can write code here in the Xcode to write some iOS specific, platform specific functions. But by all means, like once you've done this, what you need to do, like additional step is you need to build XC framework, right? Instead of straightforward building this, before building this, you need to build this XC framework. As you can see here, it's Gradle W assemble XC framework. Once you build this, actually, this is build the Swift code, right? Build this Swift code. And this Swift code would be potentially used by the Kotlin code, right? And this task is your second step. You need to build this. And this would generate a compiled library, static library, for further use by the Xcode. So it's kind of like the back and forth. You build this assemble XA framework, which it actually build Swift code, which would be used in the Kotlin compile, right? And then you build this as a second step, compile a compose app, build iOS simulator ARM64 binaries, which would be a static library and potentially being used by the Xcode. Once you've done this, as you can see, you can build it here, right? If you click this, you can see the build will be successful. Okay, cool. As you can see here, the greeting message here is "Hi, Mike from Swift." So it means the interoperation of this iOS function has been succeed, right? And I'm going to show you the desktop as well. So if you see, if we build a desktop build, let's add desktop. We may start from the main function in the desktop. We run this once, and this Gradle task will be here next time, so you can use this to build. Voila! As you can see here is hello from desktop Mac. So it means like it's actually this string in the UI is taken from each platform implementation, right? In the desktop implementation, it returns value, say hello from desktop, right? With the iOS build, like iOS implementation, it would have say hi, Mike from the Swift. So yeah, it's pretty much what we have today. Thanks for watching.